In this video, we are going to learn how to derive the law of cosines. The law of cosines is the equation c squared is equal to a squared plus b squared minus 2ab cosine of angle C. So in order to derive this, we're actually going to use the distance formula to figure this out and find the distance between 2 points. Ideally, the distance between the 2 points that make up the side C, so we can just replace D with C. So I need to first find those 2 points. The first one's easy to find. If I imagine this on a coordinate grid, if this vertex of the triangle is there and side B is along the x-axis, then this coordinate would just be b comma 0 for both of these triangles. Now I have to find out what the other point would be, and I'm going to be looking at an acute triangle and an obtuse one just to see if anything changes. So for my acute triangle, in order to find this coordinates, I'm actually going to imagine that I have a circle of radius A rotating around the coordinate plane. And I know that the sine value of an angle is equal to the y coordinates over the radius. So if I look over here, I can say that sine of, let's say, angle C is equal to the y coordinate, which I'm looking for, over the radius, which would be 1 if I imagine that circle of radius A. Now solving for y, I can get y is equal to a sine of c. So the y coordinate would be a sine of c. And the x coordinate I can find in a very similar manner. The cosine of an angle is equal to the x coordinate over the radius. So cosine of c would be equal to x over the radius a. And x would be equal to a cosine of c. So that coordinate I'll write as a cosine of c, comma a sine of c, because these are the 2 values that I should know for my law of cosines. Now, if I was looking at this obtuse triangle with the obtuse angle, the way I find this is, since I'm using a as the radius, I would still find it in the same way. Angle C, radius of a, and if I plug those in, the y coordinate and the x coordinates will still be a cosine of c, comma, a sine of c. So whether this is an acute triangle or one with an obtuse angle, you'll use the same points to show this. So now I'm going to use my distance formula, just replacing d with c. And I'll get c is equal to the square roots of x2, which I'll say b is my x2, minus x1, a cosine of c, squared, plus y2, which I'll say is 0, minus a sine of c, which is the y1, squared. I'm going to square both sides of my equation just to get rid of the square roots, giving me c squared, there it is there, is equal to b minus a cosine of c squared plus negative a sine of c squared. And now I'm going to expand this expression. So c squared would equal b squared minus 2ab cosine of c, for doing b times negative a cosine of c, and then negative a cosine of c times b. Get 2 of those. And then plus, this is a squared cosine squared of c. Can you square both those terms? And the same thing over here. Negative a squared is positive a squared times sine squared of c. And I see here I have a sine squared and a cosine squared, and they both have an a squared as a coefficient, so I can actually factor out the a squared from both of those terms, giving me b squared minus 2ab cosine of c plus a squared times cosine squared of c plus sine squared of c. which I recognize as the Pythagorean identity, which is sine squared of theta plus cosine squared of theta. And I know that sine squared of theta plus cosine squared of theta is equal to 1. That's the Pythagorean identity. So by replacing that with 1, I'll get c squared is equal to b squared minus 2ab cosine of c plus a squared times 1, which just leaves me with a squared. So rewriting this equation, I get c squared is equal to a squared plus b squared minus 2ab cosine of c, which is my law of cosines. Now what's really nice is you could do a similar argument for almost any distance on here. And I could just replace angle C with angle A, and then this formula could be rewritten as, for example, if this was A, I would get A squared would be equal to now to B squared plus C squared, the other two sides, minus 2BC cosine of A now, the angle that's here, if I were just to replace C and A, for example. And if I were to replace angle C and angle B, this formula would just change into b squared minus a squared plus c squared minus 2ac cosine of b. So it's two other versions of the law of cosines, but they all really just mean the same thing. And that's just by replacing the letters by the angles and then solving this the same exact way each time. And that is how you derive the law of cosines.